Okay, so today we're talking about something called shell models first. We're going to learn how to draw different atoms, and then after that, we're going to get into a different type of drawing, which will be a little bit easier to draw. So you guys don't need to copy this down. This is kind of review from earlier this year. But you guys should remember that this is kind of what an atom looks like. Atoms are made out of protons, neutrons, and electrons. The protons and neutrons are in the middle, and the electrons fly around. Okay. Again, you guys don't need to copy this part down. This is just kind of review. Now, electrons fly around the nucleus. Okay, and then, okay, so electrons fly around the nucleus, and basically that's how an atom looks like. Okay, so what we're going to do is we're going to learn how to draw this type of structure right here. So this part you guys do want to write down. So I want you guys to take about maybe 2 minutes or so. I want you guys to copy down the 5 rules right here. Again, you don't need to copy it down word for word, but as long as you get the general gist of it, that's totally fine. And after you guys copy it down, we will go over how to draw the actual shell model. Okay, so take 2 minutes to copy down this part right here. And then after that, I'll go over how to use these rules to draw different pictures of elements. Okay. Okay, so first element we're going to draw is helium. So I want you guys to go to the periodic table right here, and I want you guys to find helium. Helium is in the top right corner. So I want you guys to just find helium. Okay, and we're going to talk about how to draw helium. Okay, so the first rule is we got to find the number of shells that helium has. Okay, so if we take a look at the periodic table and look at helium, helium is in the first row, right? Rows go side to side. So helium is on the top, the first row. So let's write that down for our paper. Helium is on the first row, so row 1. So that means helium is going to have 1 shell, okay? So helium is in the first row, so it's going to have 1 shell, okay? So if we're going to draw helium, what we're going to do is we're just going to write the symbol He, and we're going to draw 1 circle around helium. That's going to represent the shell. Okay. Okay, so we got helium. It's in the first row, right? It's in this top row right here. So it has 1 shell. So we just draw 1 circle around it. Okay, super simple. Okay, next thing we're going to do is we're going to count the electrons that it has. And the electrons are equal to the number on top of the box. So if we look at helium, what's the number on top of the box for helium? 2, yeah. So that means helium has 2 electrons. So let's jot that down on our paper as well. Okay, it's going to have 2 electrons. Okay, now since helium only has 1 shell, okay, we're going to put the 2 electrons in that shell because there's only one place it can go, right? It's in the 1 shell. So we're going to draw helium like that. And there you go. That's what helium looks like. Super simple. Okay, all we had to do is count the rows. Then we had to count the electrons. And then we just needed to fill them into the circle. Okay, that's it. Okay, let's do another example. This one's going to be a little bit trickier. It's going to be carbon. Okay, so I want you guys to take a look at your periodic tables again and find carbon. Okay, so if we look at carbon, carbon is right here. Now, let's start with the rows. Which row is carbon on? Yeah, the second row, row 2, right? Because this is the top row, the second row. So that means carbon is going to have 2 shells, right? So it's on the second row. So it's going to have 2 shells. Okay, good catch on that. Okay, now when you guys do your assignment, you guys don't need to write all this down like 2 rows, second shell, right? I'm just doing this so that you guys can refer back to where we got these numbers and these pictures from. Okay, next thing we're going to look at are the electrons. So if we take a look at carbon, what's the number on top of carbon? 6. Yeah, so it's going to have 6 electrons. Okay, what that means is you're going to have 6 of these dots on your picture. Okay. Okay, so let's draw carbon. So I'll draw carbon right here. So carbon is going to have 2 shells. So we got to draw 2 circles around carbon. Okay, and we got to draw 6 electrons. Now, this one's a little bit different because this first example, we could only put the electrons on 1 shell, right? But now there's 2, so we need to figure out where we need to put the electrons on the shells. Okay. Now, this is what I think the easiest way to do it is. Let's start from the inside out, okay? So if you take a look at this first shell right here, okay? Okay, the first shell is represented by the first row, okay? And what we want to do is we want to take a look at the first row and figure out how many boxes there are. So if you take a look at the periodic table, let's look at the first row. How many boxes are in the first row of the periodic table? Yeah, 2. There's only 2 boxes. I know they're split up like that, but there's only 2. Okay, what that means is we're just going to draw 2 electrons in that first shell. Okay? Okay, because that's represented by the first row. Okay. Now we drew 2 electrons, so we used 2. So now we only have 4 left. And so we filled up this first shell. It can only hold 2. So we just need to put 4 on the outside shell. And that's it. That's how you would draw carbon. Okay. So the rule that we use is this one right here. The max number of electrons in each shell is the number of boxes in each row. So the first shell right here is represented by the first row. Okay, and it has 2 boxes. So it can only hold 2 electrons. And then we put the rest of them on the outside. Okay. Yeah, what's up?
Where do you see the 2 boxes?
Yeah, so if you go on the periodic table, look at the first row. There's only 2 boxes. You see it right here?
Oh,
yeah. They're split up, so that one's kind of hard to see, but it's still the same row. Okay. Good question. Any other questions? Okay, let's do the next one together. Okay, so I'm not going to have this here, but hopefully you guys copied it down already. But it's the same principle. So let's take a look at the third one, sulfur. So let's take a look at sulfur. Sulfur is right here. It's S. So if you take a look at sulfur, let's do the same process we did earlier. Which row is sulfur in? Yeah, the third row. So that means it's going to have 3 shells. Okay, so if you guys just want to draw it now, because you guys kind of get the idea, you can do that. So we're going to do sulfur, and we're going to draw 3 shells. Oops. Okay, so 3 shells. And the reason why is because it's in row 3. Okay, let's figure out the electrons now. So if we go to the periodic table and look at sulfur, what number is sulfur? 16, good. So it's going to have 16 electrons. Okay, so all we're going to do now is draw 16 electrons into our picture, okay? So if you guys look at it, there are 3 different rows, right? We're going to start from the inside out. So the first shell is the first row. We said earlier there are 2 boxes in the first row, right? So we're just going to draw 2 electrons in that first shell. Okay. Okay, so again, just remember the first row has 2 boxes. And so that's why we draw 2 electrons in the first shell. Okay, now sulfur is a little bit different from the previous one because it has a 3rd shell. So let's look at the second shell. If you take a look at the second shell, how many boxes are in the second row of the periodic table? 8, good, yeah. 1, 2, 3, 4, 5, 6, 7, 8. So we're just going to put 8 in the second shell. 1, 2, 3, 4, 5, 6, 7, 8. So the second row has 8 boxes. And so that's why we draw 8 on the second. Now, we have to have 16 total, right? We used 2 and we used 8, so that's 10. So we only have 6 left. And so these ones we can put on the outside. So 1, 2, 3, 4, 5, 6. And there you go. If you count them all up, that's 16 electrons. So that's what sulfur looks like. Okay, so hopefully not too bad. Any questions on how to do sulfur? It's basically the same thing as the previous one. It's just 1 extra shell on the outside. Alrighty, so let's go on to the next one. And you guys don't need to draw this one. I'm we're just kind of going over it for me to kind of send a message to you guys about why these shell models aren't the best way to draw these atoms. So if we take a look at Ba, barium, barium is right here on the bottom left. How many shells does barium have? It has 56 electrons because number 56, but what row is it in? 6. Okay, so please don't draw this. But if you wanted to draw barium, or if I told you to draw the shell model, you would have to do 1, 2, 3, 4, 5, 6 shells, and you would need to draw 56 electrons. And let's just be honest. Nobody wants to do that, right? I don't want to grade that. They don't want to grade that, right? This is too big. It's too much. So you guys can see as the atom gets bigger, it gets harder and harder to draw it just because they're so big. And so there was this guy called Lewis, and he said, nah, shell models are very inconvenient. We're going to draw it my way. And so what we do is we draw Lewis structures, and this is what we're going to do most of the time in this class. And in Lewis structures, and you want to copy this part down, we only draw the valence shell. Okay, valence means outside, so we only draw the electrons on the outside shell. Okay, so make sure you guys jot that down. So instead of shell models, we're going to be drawing mostly Lewis structures. Okay, and that's where we only draw the outside electrons. The electrons on the outermost shell. So we just did shell models. Now we're doing Lewis structures. And this is where we draw the outermost shell. And this is what we're going to end with. Okay, we're just going to do a couple examples and then we'll be done. Okay, so Lewis structures is where we only draw the outside electrons. And this is helpful for us because, number one, valence electrons are the ones that do stuff. So when we see things light on fire or turn into different chemicals, it's the valence electrons that are doing stuff. All the other stuff, most of the time, not doing anything. Okay, so let's learn to draw them. And this is what's going to be mostly important going forward. Okay, so let's take a look at the element that we talked about earlier, barium. Okay, now Lewis structures are very easy to draw. All we got to do is count the boxes in that row. Okay, so if we take a look at barium, it's in row number 6, but we don't care what row it's in. We just need to count the boxes in that row. So barium is box number 1, 2, right? So that means if we're going to draw barium, the Lewis structure, it's just going to be Ba, and then we just do 1, 2. That's it. That's the Lewis structure. Okay, a lot better than drawing the 6 shells and the 56 electrons. All we got to do is count the boxes in the row that it's in. Okay, and if you want to go backwards and look at the previous examples, if you take a look at carbon, it's going to have 4 electrons on the outside shell, right? And if you take a look at carbon on your periodic table, carbon is box number 1, 2, 3, 4. If you want to take a look at sulfur on the problem that we did earlier, sulfur had 6 electrons on the outside shell, and sulfur is box number 1, 2, 3, 4, 5, 6. So it's a lot easier to draw these Lewis structures than the shell models. Okay. All right, now there is one important thing you want to keep in mind, and I want you guys to write this one down. This is the only one you guys need to write down. When you guys do Lewis structures, you're going to ignore groups 3 through 12. And I'll tell you guys what that is in just a second. But when you do Lewis structures, you ignore groups 3 through 12. Okay, and this is an important rule to remember. Okay, or your Lewis structures are going to look really weird. You're going to ignore groups 3 through 12. Okay, so let's take a look at what that means by doing an example. So we're going to draw Br, bromine. So let's take a look at the periodic table and look at bromine. Okay, so if you take a look at bromine, bromine is right here on the periodic table, all the way on the right side. Okay, so what we're going to do is we're going to draw the Lewis structure for bromine. And so we're just going to count the boxes. We're going to count 1, 2, but you see this big section right here. You might be able to see it on your table, maybe not on this one. It says groups 3 through 12. We're gonna skip all of these guys. Okay, and the reason why kind of goes beyond the scope of this class. We talk about in AP chemistry if you want to take that with me next year for whatever reason. But if not, then you guys don't need to worry about it. You can just skip that section, and then we just keep counting from here. 3, 4, 5, 6, 7. So bromine is going to have 7 valence electrons. Okay, that's it. That's the important rules to remember. Alrighty. Do you guys think you could try one on your own? Maybe both. Yeah. So I'm gonna give you guys one problem that looks exactly like what's gonna be on your assignment, just so you guys are comfortable and you have an example to go off of. Okay, but let's take a look at this example and then we'll be all done. So we're gonna do my favorite element, O, okay, oxygen. And I want you guys to try drawing the shell model and the Lewis structure for oxygen. So go to your periodic table, find oxygen. And I want you guys to draw the shell model, the Lewis structure. And if you think you can fill out this information as well, you can try. You don't need to draw this table, just answer the question side to side. And then in about 4 minutes or so, we'll go over it together, make sure everybody's on the same page, and then you guys can get started on your assignment, okay? So take about 4 minutes to try out that problem. Okay, so let's take a look at O. Okay, so we're gonna get started with the shell model. So if you take a look at O, which row is oxygen in? Yeah, the second row. So that means it's going to have 2 shells. Okay, so I can actually fill this out right here as well. It's going to have 2 shells, and oxygen is going to have 2 circles going around it. Okay. Yes, and that answers my next question. It's going to have 8 electrons, and it's because it has the number 8 on top. Okay, so that's actually going to be the number of protons and the number of electrons because it's number 8 on the periodic table. Okay, so what we're going to do is we're going to fill in the shells. Now, if you guys remember, the first shell can hold 2 electrons, right? Because it has 2 boxes. So we're going to put 2 on the first shell. And then we can put in 6 on the outside shell, the valence shell, because we need to have 8 total. Okay, so that means the first shell, and you guys don't need to write this. This is just for your reference, is going to have 2 electrons. The second shell is going to have 6 electrons, because that gives you a total of 8 total electrons. Okay. All right, now we can draw the Lewis structure as well very simply. All we got to do is O and then the electrons on the outside. And then you guys can see that there's 6 on the outside. So we're going to put 6 on the outside. You can also do it by counting to O on the periodic table. If you take a look at the periodic table, it's oxygen's box number 1, 2, 3, 4, 5, 6. And so that means it's going to have 6 valence electrons. And that's it. That's basically what you'll be doing for your assignment today. Okay.